Okay, good day everyone to also those who have just joined us. Please note that now the class is now being recorded. I will start by introducing our last week topic, which is lesson number 10, which we're supposed to do on Friday. Since the recording have not yet been uploaded, I will actually then start by going through this lesson, because lesson that we're supposed to do today is a continuous lesson of lesson number 11. So just a quick confirmation. Just a moment. Okay, just a quick confirmation before I can start the lesson. Can you just give a thumbs up if you can actually see my screen? Okay, thank you very much for the confirmation. So today's lesson is going to start with graphical illustration of data. As you are aware that in a media environment, you get to work a lot with data and you also get to have to do a lot of presentation. So it is always important that you understand the best way to visualize your data so that the audience can be able to understand everything about your company or about your performance on whatever aspect that you'll be presenting during your presentation period. So under today's lesson, we are going to cover different types of data and how do they actually differ. We're also going to talk about different types of presentation of data, where you can present your data through a stem and leaf plot, line graph, pie charts, as well as bar graph and histogram. And then we'll also later on talk about the difference between a bar graph and a histogram and why is this important for you to be able to distinguish between the two. So this is just a scenario of what we call a graphical illustration of data. So this is the type of data format that you go through. So in a work environment, you get to find that you will have a certain row of data that is coming either from, that is collected through different sources, either from your IT system, which is either your SQL, or coming from your Microsoft Excel, or coming from your marketing department, which is just collected through interviews or through surveys. So at the end of the day, that data still need to be visualized for us to be able to explain the data to our audience. Without visualizing the data, therefore, it will be difficult for people to actually understand the cycle of the data that you're presenting to them. So it is important that you understand the graphical illustration or the visualization of that data. So when you work with data, we've got two types of data. We've got discrete data and continuous data. So when it comes to discrete data, this data can only be of certain values. So meaning that the data can be counted and it actually has what you call either the numbers are presented in whole numbers or integers. So the value can actually fit into a certain category. To say, for example, under discrete data, we're looking at customers that we have received or that we have serviced over the past 12 months. So those number of customers will actually be as a whole number or integer to say that during this month we did not manage to have customers. During this month we have 25 customers. So the discrete data is normally as counted as a whole number or is an integer where they can either go into negative or become a positive number. So those are the types of discrete data. So here it says that the discrete data can only be of certain value. For example, the number of customers that enter the bank to make a transaction on a different days of week, or the number of ATM withdrawals made at a particular outlet for a different month of a particular year. And then we also have got then continuous data, which is a second type of data that you can actually deal with. So with continuous data, these are the data that can take any value. They can not only be integers or they cannot only be a whole number. This type of data can also come as a form of a fraction or ratio or decimals. So those are what we call continuous data. And what they actually do is that they measure they measure a point between two realistic, they actually measure 2 points to say that from this point to this point. And the data number or the number that you'll be dealing with, like I already mentioned, they are not in terms of whole number or integers. They can continue go further into details and become fraction, decimals, or actually mixed numbers. So here it says that continuous data can take any value, and there is an infinite number of possible values. Example include the different time that an athlete can complete a 100-meter race, such as 11.23 second, or 10.13 second, 9.5 second. So they can also be used to measure temperature or rainfall. So one of the other things about continuous data is that continuous data is not as tidy as discrete data. It is it's one of those raw data that it is very difficult to read unless it is visualized. And there are only certain number of graphical illustration you can use for continuous data. Unlike discrete data, which gives you a number of options that you can use, but continuous data does not allow you to use certain types of graphical illustration. So here it says that the main difference between this type of information, or between the discrete and typical, that is that discrete typically only show information for a particular event, while continuous data often shows trends in data over time. So meaning that with discrete data, we can only focus for data for a particular year or for a particular month or for a particular period. We cannot go over any specific period and say we're looking at data for the next coming 3 years or for the previous 3 years. So discrete data does not allow that. So meaning that when we take a look at discrete data, which means that it will also get to also have got a limit in terms of graphical illustration, because there are some graphical illustration that cannot be used for discrete data because of its format not allowing to go beyond a particular event or particular year. So some of the difference between the discrete and continuous data value are as follows. You have got, in terms of value, discrete data represent exact figures you can count, such as the number of students in class, whereas continuous data often includes a measurable value representing a range of information, such as to the extent of the difference between the shortest and the tallest student in class. So meaning that you'll be measuring in terms of centimeters, and those centimeters will always be having a decimals on top of them. So meaning that we're not dealing with full numbers. And then types of data. Discrete works with integers, which are whole numbers, whereas continuous often use fraction and decimal. And then when it comes to methods, you can usually measure discrete data using simple methods such as the number line or bar chart. And when it comes to discrete, so discrete becomes more complex, so meaning that you can only use things such as curves or histogram or bar graph as well. And then time interval, so typically discrete data remain constant over a specific time interval, whereas continuous data can be used for various interval of time. So meaning that we can include a number of specified time interval which can range from any point to any point, unlike the discrete data. So to represent our data, we have got the following types of graphical illustration that you can choose from. So these are the 5 types of graphical illustration that we're going to talk about during this lesson. So the first one, we've got the stem and leaf plot. So I'm just going to read the explanation on all of those. So the stem and leaf plot, it says that in the stem and leaf plot, the data are organized from least value to the greatest value, the digits of the place value of the leaves, and the next place value digits from the stem. So what actually happened with the stem and leaf plot, we use a system that is sort of like a tree system, sort of like to say that this is the stem and these are the branches and then these are the leaves. So what we actually do with the stem and leaf plot is that we then get to separate data or group data based on smaller categories, and we identify how many digits are within that specified categories. And we still maintain the same format of the same number to say that if it is 23, it will still be having the same representation within the graphical illustration. It will not change, it will be still read as 23, but it will also give us the numbers of item or the number of data falling within one specific category, to say that this category have got 15 data, or have got 4 datas, and those datas are counted as leaves, and then the categories are categorized as stem. So that is the stem and leaf plot. And then we also have got a line graph. So a line graph is usually a linear graph that is used to display continuous data, and it is useful to predict future event over time. So this one is the most commonly used type of graphical illustration in each and every industry. So each and every industry gets to use a line graph, but the most common place that you will find this, it's actually in medical, because in medical, for them to predict the future as well as to predict your sickness, your continuous way of how you're going to be sick in the future, to predict how long you're actually going to live, we get to use what you call a line graph to actually get to then estimate, to say what is the possible future, what are the possible future event that might occur if this thing continue at this certain rate. So we get to use a line graph. So a line graph is referred as a linear, where a linear, we get to use something called a linear regression equation to actually then estimate or perform a line graph, which is also known as y equals to mx plus c. This is called a linear regression equation, which is used to identify the line graph. And then we've got the pie chart. So pie chart are also known as a circle graph that shows the relationship of parts of the whole. So the circle is considered with its complete as 100%, and each and every item will be placed as a category or will be placed as an event that will be representing a certain portion of the total whole number. To meaning that when we perform pie charts, we need to actually first identify the total number, and then after that we identify how much of this particular category or this particular item hold as a portion over the total percentage or over the total number. And then we've got the bar graph. So in terms of the bar graph is used to display category of data, and it compares the data using solid bar graph to represent quantities. And then we've got histogram. The histogram is almost similar to the bar graph. So the graph uses bars as well to represent the frequency of numerical data that are organized into intervals. Since all the intervals are equal and continuous, all the bars have the same width. So meaning that we cannot have bars that are of different width. So there is always gonna be having the same width, but the length and the height will actually differ based on the data represented. So one thing before I move forward, so this one, the bar graph represents, it says that it uses solid bars, and then it represents data in category. So normally when we talk about the bar graph, so the bar graph will normally use what you call your discrete data, and then your histogram will normally use your continuous data, because here we'll be talking about frequencies, and where frequencies can actually go from ranges that are beyond whole numbers and integers. So frequency can be in a form of from say 92.2 to 99.9%. So this means that our data will not be stable. So meaning that we'll therefore get to use the histogram for continuous data and the bar graph for discrete data. So meaning that the two cannot be used on the other different types of data. So meaning that you'll have first to identify which type of data you're dealing with, and then you can be able to identify whether it is best possible or it is which one is best fit the type of data you're dealing with. It's either the bar graph or the histogram. And when you are representing your data, it is important that when you present your data have got the following information within your graphical illustration or your graphical visualization. So it says that there are certain rules to effectively present the information in the graphical representation. Your data need to make sure that it have got a suitable title. The title explain what the data that you have just visualized or that you have just presented in a graphical format to say that this is what this data is actually talking about. So you need to make sure that the appropriate title is given to the graph, which indicates the subject of the presentation. Following thing is the measurement. The measurement, you need to mention the measurement in unit in the graph. So either you're working with rand or you're working with numbers of people, you're working with month. So it means that your data, your measurement needs to be labeled as well, and it needs to be accurate. And then this brings us to what we call the proper scales. So to represent the data in an accurate manner, you need to choose a proper scales. So when you choose the measurement unit to say that you are going to measure your data in month, so which means that you can then also go and say that we are going to measure this on an individual month. So that will be your scale. Or we're going to measure this on a quarterly basis to say from January to March. So this means this has to as well align with the data that you've actually collected or you are using. So if your scale does not go in hand with the data that you have, the presentation will actually be not neat. So what is important is that, for example, you find that you have got data that is having information that is sitting, a majority of information are in millions, and then the lesser majority are in thousand. And you go and choose to say that my units are going to be measured in thousand, whereas majority are actually in million. So meaning that the scales that you actually use will be completely wrong, because now you are going to be having to represent a higher value that is sitting in millions term, and then you also have to convert that number into the million numbers into thousands. So that means that your data will now be less neatly, which is the last thing that you actually need to say that choose the correct size, font, color, etc. in such a way that the graph should be a visual aid for the presentation of information. The second thing is the index. The index is the appropriate color, the shade, the design that the graph for a better understanding. And then you also need to include the data source. Where did you get the data? This is very important. Are you presenting information that you just created out of thin air, or this information have got a source to say that this is where I got the information? If you got your information from which you extracted from your company server, then you could indicate that this is coming from our company server from this specific date it was extracted. If the information, let's say it's coming from, you took the information from SABC, you're gonna say that this information is coming from SABC. And one of the last thing, keep your information or keep your visualization simple. Construct a graph in an easy way that everyone can understand, even without you having to explain much. Your graph should already give indication of what you are actually going to talk about. So meaning that by the time you present your information, people already have a clue or an idea of what this presentation is all about and what is it measuring. So you'll also be telling them key information that might not be presented in the graph based on the chosen graphical illustration. So before we start with the stem and leaf plot, are there any questions that you might have? Guys, are there any questions that you might have?
Not from me.
No, sir.
Okay, I think then we can continue. So with the stem and leaf plot, you are going to have a stem and then you're also going to have a leaf side. So the stem, as I've already explained, the stem represent the categories and then the leaf represent the data that you've actually counted for that specific category. So here it says that the stem and leaf plot is a way of presenting quantitative data in a graphical format or diagram, and it's a way of grouping your data into classes, which are also referred as category. So the good thing about this is that from the diagram, you can be able to obtain the original data, so no information is actually lost. Unlike when you're presenting your information in others, you might find that you actually have to summarize the information, or the information or the data can actually be lost because most of the other stuff you actually have to calculate the average. If you, for example, if you're using a pie chart, your information could actually be lost because now you'll be talking in terms of percentage over a specific over the whole chart to say that this is how much this worth in terms of portion. And then you can also tell the data, but for people to actually get to understand that, because it might be also a bit difficult because some data is lost because no numbers are actually represented. So here it is that an example. We've got the following data sitting in this following format. So what we do is that we look at our data. So this is our data. We take a look at what is the trend between our data. Is our data sitting in terms of the tens format, or is it sitting in terms of the hundreds values, place values? Or is it sitting in terms of the thousand place values? So we get to identify that first, because that's what identifies our stem classes or category. So if our data is sitting in terms of tens values, for example, there are only 2 digits, so this means that they are in tens values. So this means that our stem and leaf plot will actually be based on tens values. If we're looking at data that is sitting, would say that we have got 101, 130, 171, 125. So when you look into this data, you will notice that the data is sitting in terms of hundreds values. So this means that when we get to present our data, we're going to present this data based on the stem and leaf plot that is on the hundreds value. So when we present this on the hundreds value, this will represent 100, this will represent 200, this will represent 300. So if you're only going to be working with hundreds values that are within the 100 format, then you're gonna say 11, you're gonna say 10, 11, 12, 13. So this will actually means the values are in hundreds, the values are in 110s, the values are in 120s, the values are in 130s. So that's how you get to identify the category. So you need to be able to read the data, identify the most occurring types of place value that is there within your data, and then you can be able to identify your stem to say that my stem is going to be categorized in tens values or in hundreds values. So tens values will be 1 digit, hundreds values will be 2 digits, thousand values will be 3 digits in terms of the stem, and then 10,000 will actually be 4 digits in terms of the stem. And then after, once you identify that, on our data, they're in 10th value. So if they're in 10th value, you can also have got 0, 1, 2, 3, where 0 represent the ones values. To say if we have got 5 in between here, then you're gonna just say 5. So this will be read as 5 in terms of reading this stem and leaf plot. So on this one, the values that are in 10th value or format, we've got 15. So we're gonna say the first leaf that we're going to put, we put them in order of the format. So meaning that you first need to organize your data from the smallest digits to the highest digits. After that, you're going to place them in a leaf plot to say that in terms of the tens, what is the smallest leaf, or what is the smallest digits that comes after. So I've got 15, so you're gonna put your 5 first, and then you're gonna move forward. 16 is our second, If there's nothing, you pass to the second category. So our second category is 20, representing a stem of 20s. So we've got 21, so you're gonna say 1. We've got 23, you're gonna say 3. You've got 23, you're gonna say 3. You've got 26, you're gonna say 6. You're gonna 26, you're gonna 26. So when you read this will be read as 21, 23, 23, 26, 27, because they're following within the category of the stem that is within the 20th category. So that's how you get to read the stem and leaf plot. And then these are counted as leaves. So if you want to identify the total numbers that are within this data, so we just come and count the leaves. So here we've got 2, here we've got 1, 2, 3, 4, 5. So here we've got 5 leaves, here we've got 2 leaves, here we've got 1 leaves, and we just add all of those leaves together. So we've got 2, 7, 9, 10. So in total, we have got total data set. So meaning that our data is compiled of 10 individual digits, which are starting from 15 to 41. So even if you come and count, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can also be able to count that through the list to say that our numbers or our row digits are actually 10 and the leaves are as follows. Most of them, they are coming from the 20th category. So this is how the stem and leaf plot actually works. Unfortunately, this I'm not going to test it on the stem and leaf plot, but on other graphs you will be tested on. So please be aware of that. You will be tested on other graphs, but except the stem and leaf plot. I feel like it's a bit old for us to work around with. And then we then have what we call a line graph. So a line graph is useful when presenting data that changes continuously, and it is also known as a linear graph. So it says that the line graph displays quantities, values over specified time interval. In finance, the line graph usually is used to display the historical price or cost. And in a media environment, it can be used to display the numbers of viewers or listeners of a channel being broadcasted in a TV or a radio show. To say that, let's take a look at this example or illustration over this side. We have got average daily media consumption per person worldwide. If you take a look from 2009, we've got two different types of media format. We've got the TV and we've got the internet. Back then, internet was very scarce in the early 2009s. So it was mostly found at people who are actually rich. They only have access to the internet, and those who are actually in a work environment. So meaning that users were mostly people who are either in a work environment or people who have got who are in those upper class individual who can access or be able to afford it. And then as time continues, you will notice that the internet usage started to increase as things started to become better. When the economy is also becoming better, standard of living is increasing. People started losing interest over TV because of now accessibility to internet, which gave them access to much more information than what the TV was providing during that particular period. So as time goes on, currently this chart, when it continues going further, it end up looking like this. To say that at some point after 2016, the internet became the most used media tool or system more than the TV system, because now people are no longer interested in the TV. They started using much internet because it's providing more information than what the television used to provide. I'm sure nowadays the TV, if we were to look at this chart, we'll just put it the opposite way. That will actually represent the data. And as you can see here, we're talking about consumption. So you will see that people used to spend 188 minutes on TV and 48 minutes on internet. And then since as time continues, as time grows, you will see that people have now spent more hours on the internet than they've spent more hours on the television. This is also because of work, new work changes, as well as the way of living that have actually come. Right now, we are living in a fourth industrial revolution where there is AI, there is everything is done online, marketing. People no longer watch TV for adverts. They can just go and advertise on the social media platform. So this means that the internet consumption will actually be more higher than the TV consumption, meaning that less people will actually watch TV and most people will actually be on the internet and they'll spend more hours on the internet. Like what we are actually doing now, we are using internet to conduct our classes. So which means that more hours are also spent on internet rather than on TV, meaning that if we were to take a look into this in terms of our current condition, back then we would have been in class, but now we are actually using internet to conduct classes. So meaning that we have reduced the time of actually going into face-to-face classes by actually conducting online classes. So if you take a look at that data chart as well, you will notice that most classes have now been conducted online than have been conducted on a face-to-face over the number of years as we continue. So the line graph, as we already mentioned earlier on, it represents information over a number of specified time frame. As you can see, the data is coming from 2009 to 2016, and this is a line. So with this line, we can be able to predict future event and see how and when will the internet be at its peak, as well as the TV actually come into end by actually using a linear regression equation to predict the future. So we get to use the y equals to mx plus c. So this is the most important type of tool that you need to understand. So if you do not understand this equation, make sure that you understand it, because it is very useful in life and you will find it across a number of information that you'll have to apply this. And then this brings us then now to our pie chart. So the pie chart is a circular statistical graphical which is divided into slides to illustrate the numerical portion. So one of the things that I would like to pick up is that a pie chart shows data at one point in time. So meaning that we cannot use a pie chart to represent data from 2012 to 2020. We can only use the pie chart to represent either one of the years in between 2012 and 2020. So we cannot represent all the data from the all years. So that is one disadvantage about using the pie chart. So to present the data in a pie chart, you need first to calculate the total value of the entire data and then calculate a percentage of each point or a portion of each point that it has on the total value. So you cannot be able to do a pie chart without first calculating the total value. And each and every illustration here, representation a portion of the total value. To say that favorite types of movies, people who like favorite types of movies in our class, those who like sci-fi are 4, those who like drama it's 1, those who like romance are 6, those who like action are 5, those who like comedies are 4. So for us to be able to put this in a data format, first we need to add up all the total number of individuals that were interviewed in terms of favorite types of movies. So that will be 4 plus 5 plus 6 plus, so all of these will actually end up giving us a total value of 15. So that will be the total value. So meaning that for us, once say 15, we can be able to identify the portion, to say that what is the portion of this amount over this specific portion or over this specific event. So talking about movies, so we've got 1, 2, 3, 4, 5. We've got 5 categories. For each categories, this one we've got 4 people that loves it out of 15. So 4 out of 15, then to actually give you a certain portion to say that out of the 15, the sci-fi portion have 20 viewers or 20 people who like to watch the sci-fi movies. So that is the pie chart. So pie chart can only be used for one specific point in time or one specific event. So meaning that the moment your data have got a number of series in terms of time frame, then you cannot be able to use a pie chart. If you are working with data that is representing numbers of listeners over one specific month, then you can be able to use a pie chart, because we're looking at one specific time frame to say that from this whole month, we've got 4 weeks. So on which week did we have how many numbers of listeners? Then you can be able to use a pie chart. And then also, if you're looking at one specific event, which is a year, you can put the data in terms of month to say that how many customers do we have, but you cannot break that down and say then how many customers from which department came from which product and which product. That will no longer be able to apply. So meaning that there only has to be one specific event, one specific category. The moment there are two categories, the pie chart no longer is in place. So, and as you can see, the pie chart only gets to be applied on discrete data. It can no longer be applied on continuous data. It only needs discrete data because we're looking at one specific point of time. And then we've got the bar graph. The bar graph here represents, it says that the bar graph is a chart or graph that represents category of data with rectangular bars with height and length. And one of the most important things is that the bar graph shows comparison among discrete categories. One axis of the chart shows specific categories being compared to the other axis representing measurable values. So when it comes to the bar graph can either be vertically or horizontally. So here we've got the information that bar graph can be either vertically or horizontally, and one of the most important thing is the discrete data, and also the distance between the bars must be exactly the same. So the gap in between here must always be the same. When you split your categories, make sure that the difference between them are the same, as well as the width of your bars needs to be the same as well. The only difference that will not be the same is the height of your graph. And a title should be added to the graph. And here it says that the width of the bar must be the same to allow for comparison. And then we also have got a histogram. So a histogram is used to represent a specific frequency or a specific range of data. So like I did mention, this one is normally used to present data that is in continuous format. So here within this, you'll be able to see that we're talking about grades on an English test, where we've got grades on the quiz, and then we've got number of people that scored within that specific frequency of data. So to say people who scored between 40 and 50, here we've got 15 people. And then people who scored between 50 and 60, here we've got 22 people. People who scored between 60 and 70, here we've got 34. And then people who scored between 70 and 80, we've got 43 individuals that have scored within that. So we get to use a range, meaning that here we can have people that scored between 42.5 and people who scored 47. So meaning that the digits or the frequency can include whole numbers, can include decimals, can include fraction as well. So we work with this kind of data, which is continuously, for us to be able to use histogram. So here it says that similar in appearance to the bar graph, the histogram condenses a data series into easily interpreted visual by taking many data points and grouping them into logical range or bins. And one of the most important things is that you get to lose. Once you present the information in a histogram, you also get to lose the value of the data, because now you don't know who scored how much and who scored how much. You just only have got a range to say that people who scored within this range are actually this much. So meaning that you also get to lose the value in terms of data. So meaning that you are not sure who scored 40, you're not sure what is the average in terms of people who scored 45, how many people scored 45, how many people who scored 47. It just tells you that people who scored between 40 and 50 are actually 15. Whether these people, all of them scored 49, you will not know. So meaning that the data value is actually lost, but it is actually presented in a summarized format. So here it says that the height of each bar shows how many falls within into each categories, and you decide what range to use. So you will decide the range based on the repetition in terms of the place values. If your data is sitting mostly in the place values within the tens, then you can put your data based on the tens to say that from 10 to 20, 20 to 30. If your data is sitting within the hundreds, you will say 100 to 110, 110 to 120. If it's sitting within the hundreds alone, to say 100, 200, 300, then you'll put your data to say from 100 to 200, 200 to 300. So you will see that the bars will be the same in terms of the width, and they will be all connected because here we are using frequency or a range so that we can be able to present that data. So the difference between the two will actually be on our next lesson, which I'm going to explain now within the next coming few minutes before we adjourn the class at 2 o'clock. Any questions so far on what we just explained? Any questions?
Yeah.
Yes.
I have a question on the pie chart, right? Since the pie chart uses percentages, you said that we add the totals of the amount of people that watch the movie, and then how do we get to the percentage? I think I missed that. How do we get the percentage?
Okay, on this, the first thing that you need is the total. So here we're looking in terms of total people that were actually interviewed. So in terms of favorite movies, we'll look at the numbers of each and every category, how many people favored this category. So that will actually then, when we add all of that together, will then actually gives us to tell us that these are the total number of people that were actually interviewed. So sci-fi, we've got 4, drama +1, romance 6, comedy 4, action 5. So we add all of this together, it gives us 15. So then to identify the portion of sci-fi, it will therefore actually be 4 out of 15. We apply a ratio. So a ratio will actually give us a portion to say that from the whole 100%, sci-fi represent how much of percentage or in terms of the ratio. So we get to use our calculator to do that. So that will be 4 divided by 15 multiplied by 100. So that will actually give you sort of like 26%. So here the ratios, as it's just a part of graphical illustration, will actually be incorrect. So this is how we get to identify the percentage. So this will be 26%, and then you do 1 out of 15. This will be 6.67%, or if we round it off, this will be 7%. So this was just created just for illustration purpose. The digits here, they're a bit incorrect because if you calculate, you will notice that this percentage given here will not actually give you the exact number. 4 out of 15 will never, 4 out of 15, it's actually what we call, it's not a proper fraction. It's gonna give you what we call a recurring decimal. So meaning that if it gives you a recurring decimal, already the numerator it's an even number and the denominator it's an odd number. So meaning that the fraction will never be will never give you an answer that is going to be what do you call this, a whole number. So meaning that it's actually going to give you a recurring number. So that's why here, these are just for illustration. So I hope I help you in terms of identifying. So the first thing, add all the numbers, get the total. Once you have the total, calculate the portion each and every category represent over the portion. So to say that people who like sci-fi are 4. So 4 out of the total number of people that have been interviewed are 15. So the portion is actually 26%. So meaning that out of the 100% categories of movies, sci-fi takes 20% of that, of all the movie categories or all of the people who have been interviewed. So that's how you calculate the percentage. And
thank you.
And one last thing, when you plot this, make sure that if it's 26, if you've got, for example, 26 and you have got 24%, make sure that the ratios of these between the two are not the same. So meaning that you might be required to use your Canvas as well as the other tool that you find on your mathematics tool set, that toolbox that you get from your mathematics. So you'll be required to use that. So be able to calculate 24%, which is it's going to be a specific angle within your whole circle format, which is your following the first, second, third, and fourth quadrant. So you'll still be able to apply that. I managed to answer your question.
Yes, sir. It makes sense. Thank you.
All right. Then one last thing that we're going to talk about, this will not take long. It's actually the difference between the histogram and the bar graph. This is supposed to be today's lesson. So under this part, the histogram and the difference, I'm just gonna go straight to them. So this is just a revision of what we did. You can take a look into this. So this is re-explaining. So here are the difference between the histo and the bar graph. So one of the most important things is that the histogram uses continuous data, which means that it works with non-discrete variables, whereas the bar graph works with discrete variables, which means that your data needs to be a discrete data. And then the bars touches each other on the histogram, whereas on the bar graph, the bar never touches each other. And there are space in between, and the difference, the space in between, it's supposed to be the same space. So meaning that if you are spacing, it's 2 centimeters, it means that on each and every bar, between the difference between every bar, should have a space of 2 centimeters. And it says that in this type of graph, the elements are grouped so that they are considered as range, whereas on this side, the elements are taken as individual, or they are also grouped and called a cluster. And when you call them cluster, this cluster will actually be sort of like an individual category. It will not be a range like from the histogram. So meaning that this side we can just say quarter one, where quarter one will be representing Jan, Feb, and March. And then we have got another category saying quarter two, representing the information from just like that. So even if we're looking at one specific data to say that we're looking at a number of listeners for this specific radio show, January to February, which is the first quarter, then you'll represent your information. You'll represent your information for the second quarter with 3 bars, and then the space in between the 2 quarters will be the same. And then in terms of the histogram, we're not going to have this kind of information. So here we're just going to have a range to say that listeners who are between the age of 20 to 30, listeners who are between the age of 30, from 30 to 40, listeners who are between the age of 40 to 50. So we can still be able to use, but as long as when it comes to this data, we'll therefore be talking about a frequency. We'll no longer be talking just only about individual information. So the data needs to not to be discrete in format, because we'll be talking about people who are within the certain age. So we need to have a range. Whereas on the bar graph, we don't have a range, we just have categories, where the categories do not represent frequency, but just represent individual components. And another difference is that the histogram width may vary, whereas the bar chart is mostly having equal width. So meaning that that side we might have 20 to 30. It might be a very small portion, but then when we talk about 30 to 40, you might find that the other one takes a bigger portion, depending on how your data set is looking like. Because let's say, for example, you don't have people that are within, you only have one within the 40s. So if you have got one within the 40s, or let's just say one within the 50s, so this will be the 40, one within 40 and 50. So meaning that here you can just have a smaller line because you only have one individual. You don't want to waste that bigger space. And then the other difference is that the data points are grouped and rendered based on the bin value, whereas here in the bar graph, each data point is rendered as a separate bar. And one last important thing is that we cannot rearrange the blocks. So when you're working with range 20 to 30 to 40 to 50, you cannot rearrange this and say 40 to 30 and then 20 to 50. It cannot work on the histogram. Whereas on the bar graph, you can rearrange and say that let's start with Q4, or let's start with December, November, and you can work around it and rearrange. You can even put the January in between, the February anywhere. So you can rearrange this and put it from highest to lowest, or from lowest to highest, or from first quarter to third quarter. Whereas on the histogram, the range can no longer be rearranged. So once you've got a frequency or you have a range, it is done. So it means that it stays the same way. And then we've got advantages of using a bar graph. So you can use a bar graph with numerical or categorical data, which we will refer this as cluster. The bar graph displays each data or category in a frequency distribution, and it shows relative number of proportion of multiple categories. You can summarize a large data set in a visual form, estimate key values at glance, display close numbers or proportion outline. And the disadvantage is that it shows the frequency of occurrence of a different data value, and useful when calculating. It's the disadvantage of histogram, sorry. It's useful when calculating the capability of process. It helps to predict future performance on the process. The histogram allows you to show the frequency of occurrence of data along with an interval. Whereas disadvantage of the bar graph, it fails to reveal the key assumption, the causes, the effects, or the pattern. And you need additional explanation with the bar graph to explain that on this month we've got 40 people that we sold this item to, or 40 customers, or 40 listeners. And the reason behind that is because of this. Whereas the disadvantage of the histogram is that in the histogram it's not easy to compare two data sets, because we're talking about two different types of category of frequency of occurrence. To say that people listening between 20 and 30, and from 30 to 40, you cannot compare the two. So meaning that you cannot go and say that the data setting that we've got listeners who are within the age of 20 to 30 and 30 to 40. So you cannot go and compare these two data sets. So it uses only with continuous data, not allow you to read exact values. That's a disadvantage. Like I did mention, that you lose value of your data. So no one could actually know how many who is actually within the age of 25, who is actually within the age of 26 or 29. So you don't get to know that. You just only get to know that we have got 15 or 20 people who are within the age of 20 to 30 that listen to our radio station, or that follow our journal page. And it says that the use of interval in the histogram prevents the calculation of exact measure of central tendency. So those are the disadvantages. So this is the summary in terms of presentation. You'll see that the bar graph have got gaps in between, and the gaps are the same, and the width as well of the graph are the same. Whereas histogram, there are no gaps. And here you will see that here we've got range, which is the frequency, and then here we've got categories. So those are the main difference in terms of visual presentations. And we've got types of bar graph. Types of bar graph, we've got horizontal, vertical, grouped, which is multiple bar graph stacked, and we've got stacked bar graph. So in terms of presentation, this is a horizontal bar graph. It's laying down from left to right. Your bar graphs are starting from your left side to your right hand side, whereas vertical I think one it's the other way around. This one is supposed to be the other way around, the vertical. So vertical will be starting from the bottom to going up. And then in terms of stacked, you'll be having one category representing 3 different types of items within it. So this is what we call a grouped, sorry, not stacked. This is what we call a grouped bar graph. And then when we talk about stacked, so instead of having them individually separated, you will then show them in one category, starting with the smallest, then the highest goes on top of the other one, to say that this one starts from the bottom, but it goes beyond up to this point, and then this one goes beyond to this point. So when we read this data, this one will say that on January, the sales for sunglasses, which is shade 3, it's 1,000 or it's 10,100, and then the sales for shade 2, it's actually sitting at 700 or 7,000 or 6,000. The sales for shade 1 is actually sitting at 4,000. So all of this data, you'll still need to be able to read the data by just looking at the graph, which is just the stacked. So which is the same as this one over this side. So this side, each and every individual, each and every product, it's listed separately on its own bar. But whereas this side, you just only have one bar that is having stack on top of the another one. So we have got stack 1 and 2, which is representing the higher sales over that specific month of January based on the 3 products. And I think this then brings us to the end of our lesson for today. So I will do a recording for Friday lesson, as well as this one will also serve as a recording for Friday lesson and today's lesson. So I'm going to upload this, and then they'll also be linked on Call Campuses. So you'll be able to get these as well on Call Campus. So one important thing is that I want to emphasize, please guys, do not miss the next week opportunity to get to write a practice test, and the Friday part to receive your feedback on your performance and what you need to improve. So one thing that I'm going to do next week is that when you write your assessment, please come prepared, study. So what I'll suggest is that on the next coming 3 days, study everything from chapter 1 to chapter 2, the same way that I've given you the brief of your assessment. Study based on it. Come prepared. I will not allow you to have your textbook with you, even though on the assessment you'll have your textbook because it's going to be an open book. This time around on a practice test, I will allow you not to have the book so that I can be able to test your understanding and how far in terms of your studies have you gone in terms of trying to learn this without having to refer back to the textbook. Then on Friday, I will give you feedback on what areas to improve, as well as to give you to go through the memorandum of the practice test so that you are aware of what ways you're going to be assessed and what type of marking criteria is going to be used on terms of your assessment. So please make sure that next week you do attend and you come prepared to write. Bring your own calculator. No borrowing of calculator will be allowed. So I'll treat it as if we are writing your normal formative assessment. So any question? Any questions?
No,
Okay.
sir.
In absence of question, please enjoy the rest of your holidays and please be safe. I'd like to see you again next week, Tuesday, and all the best in terms of your holidays and traveling. Travel safe. Let's meet next week.